Hi, we have come to the last part of the logarithmic series, and we will be looking at what we call the logarithmic graph. First of all, we'll look at some shape and characteristics of the logarithmic graph. Then we look at the domain, the range, the asymptote. And lastly, we talk about the relationship with the exponential graph. Now, if you look at the logarithmic graph, how does it look like? Well, I will actually, I use decimals and actually key in a factor where the a can be toggled around, but I'm going to choose that a is going to have to be more than 1. So for example, in this case, I choose a has to be equals to 2. So I'll be looking at the graph that says y equals to log base 2x. Now, what are some of the key characteristics of this graph? First of all, if you look at the graph, it goes from the bottom left and rises up to the bottom to the top right. So what do we say is that we say that this is increasing. It's an increasing curve. There is an x-intercept where at x equals to 1, so the x-intercept is 1, 0 by letting y be 0. And notice that it's only defined for x more than 0, which means to say that there is no cases where x will be equal to 0, and therefore there is no y-intercept. And if you look at the range goes from negative infinity all the way up to a positive infinity. So the range is the set of all real numbers. Now we know that the domain is x more than 0. We know that the range is R. We know that the asymptote is x equals to 0. That is the y-axis, by the way. But how do we find them? How do we find the domain? Now, in general, how do we find the domain is that we must recognize that log can only be defined when fx is more than 0. And as a result, what do? We basically solve it. We solve fx to be more than 0 in order to find the domain. And now, how do we find the range? Now, the most obvious way to find the range is to first sketch the graph based on the domain. Remember, this must be based on the domain. And this doesn't just apply to the logarithmic graph. It applies to all other graphs as well. And after you sketch the graph based on the domain, you try to check and observe what is the minimum y and what is the maximum y. And from there, you will be able to find the range of the function. Remember, the range is associated with the y values. It's the range of possible y values. And lastly, how do we find the asymptote? Now, asymptote is closely related to the domain. We know that the domain is fx, is to solve fx more than 0 in order for it to be defined, which means to say that the limiting value is when fx equals to 0. Asymptote is a imaginary line that the graph tends towards but never actually cut it. So the limiting values is really at fx equals to 0. So what do? We solve fx equals to 0, and after solving it, that is the equation of the asymptote. In this case, this is a vertical asymptote, so you get x equals to a certain value. Now, we are interested to look at patterns in mathematics. And what we can see is that log base 2x, it's going to be related to y equals 2 to the power of x. They both have the same base. They are related in some sense. But how are they related? If you look at the screen here, you get log base 2x, you get log y equals 2 to the power of x, you get y equals to x, and that is the imaginary dotted line that we see. Now, what we see here is that the log graph and the exponential graph with the same base, they are basically reflections of each other on the line y equals to x. And why is this reflection happening? It's because 2 to the power of x and log base 2x are basically inverses of each other. They are inverse functions of each other. Now, many students will always realize that, hey, it's very hard to remember the shape of the graph. Well, no need to be so worried. We have some fortune telling over here. So if you look at the exponential graph, look at your right palm first. The exponential graph is the curve on the top right. And then if you have the line y equals x, it's on the middle line of your palm. And if you look at the log graph, it is at the bottom of your palm. So This is fortune telling, or is it not? In exams, if you forget, remember to read your fortune, your good exam fortune, on the right palm.